Hey, what's up, guys? Let's do try. So this is basically 208, implement try prefix tree. It's a pretty straightforward question. So just so if you don't know what a try is, say this is our root node, and I have something, let's say maybe A, B, C as a word, and now I'm gonna add a D. Okay. Now maybe you're thinking I can add like this, A, B, C, D. I want to just add A, B, C, D. But that would defeat the purpose of try, right? I just want to add D here, and I'm going to label this as a word and D as a word too. Okay, so that's all we needed to add, just a one letter D and prevent that duplicate thing again. That's what try are good at. So basically autocomplete, word search too. This is where try gets their most use. They save you a lot of time complexity. So let's see, how do we even do try then? Well, I drew this diagram where I said like A, B, and C, right? Everything has its children, right? Suppose we are only concerned with lowercase letters, which would mostly be the case. So lowercase letters are 26, A to Z. Just consider these are lowercase if I'm drawing it in uppercase, don't mind. Anyways, everything can have 25 other stuff, right? Or 26 other stuff, I should say, not 25. My bad, 26. So A can also have A, can also have A, can also have A. Why not? So how do we do this? Well, we said that everything has a children, everything also needs to be defined whether if it's the word or not, and everything has a value. So can we represent this information in a class? And if we can, that would make our task pretty easy. So let's create a node class. This is our node class, which exactly does what we just discussed. Define a character, define whether it's the word, or define the children, and then we have two constructors. One is empty, and one just takes a parameter of character C. So finally, this was what we were given to fill. So insert, let's actually talk about insert now. You would see how easy this is. Say this is our head. Cool. And let's say we also want to have a reference in some another node. Let's just call it node. We don't want to really remove head. You really don't remove head, even in linked list, right? So say I want to insert A. So I'm going to say like, I want to insert A. But how do I insert A or whether I know if A exists or not? Well, I can just check that if C minus A is null, then there's no children and I can definitely insert my own node. Why C minus A, you may ask? Well, it turns out C is a character and minus A, when you do this, you're gonna get the integer value out of it. Basically what we are doing is ASCII. So the ASCII values of it, we're just subtracting two ASCII values, getting an int, and then we're able to access our index in our array. Cool. That makes sense, right? Nothing too fancy. This is a neat trick. You should definitely remember that. So, okay, once we are done that, we've said like, okay, so A minus A, right? The ASCII value of this, whatever ASCII value of this A is versus minus this, all I know is it's gonna give me 0, integer, right? Makes sense? Both are same, would give me 0. So I guess to node children 0 equal to new node C. C in our case right now is A. Character A. Cool. So now I inserted A. Very cool. My node was here. But now I want to update this node to actually point nothing but here so that I can add more children to it. Straightforward, pretty much, right? So in the for loop, we are going to continue to do this process again and again. So B, then the node comes out here, then we add a C, and the node then comes out to be here. Straightforward, really simple, right? So, well, before I clear this drawing, I want to point out one thing. Remember we have is word. So once we fully inserted and exited out of our for loop, we can just say that this is a word, right? The word ends on C. So ABC is a word. So C can be marked as a word, which defines that everything above to this point constitutes a word. Straight enough? Now we have more methods called a search and starts with. Search and start with are basically the same thing, except search has just one additional little thing. All right, let's start again. Same example we're going to use, okay? So we have A, we have B, and we have C, right? And suppose somebody also added D and a B, right? This is a try. So now I'm given a word to search. Keep in mind, I'm given a word, a whole word. They said search AD, okay? So we first initialize our pointer to our head. So head points here. Our node also points over here. We go into its children and say in a for loop that I want to search A and D. So does the character A exist in my try? Well, yes, it does. So I update my node here. Then I say, does the character D exist? It too does exist. So my node just gets shifted here, right? Okay, my for loop done. Perfect. Found A and D. Nothing much we can do here. But remember there was this is word, right? Is AD a word? No. C is marked as a word. B is marked as a word. But D is not marked as a word. So, well, since this is not marked as a word, we have to return false. So an extra condition outside our for loop would be if node.isWord is false, then return false, else return true. Right. Now, suppose I said, I don't want a word. I just want to see prefix, that something starts with AD, right? We do the exact same process, A, D, but this time I do not check this condition. And I directly return true. And that's basically your starts with this. So that's whole try. That's how you implement the try. And you might not believe me since it's super simple, even though it's very efficient, sounds very fancy. Try. Hit submit. Here you go. So 49 milliseconds, 26% faster. Well, there's the same solution, 249 milliseconds. It's just how LeetCode works. So I'm also writing this in C#. If you write it in Java, you're gonna see way faster time. So let's run it again. Here goes my point. 244 milliseconds, 94.92% faster. So this is the whole perfect solution, optimized solution. Another approach you can take is if you do not like arrays, you're like, who's going to do C minus A? What you can do is define a hash map. In C#, it's called dictionary. And one added benefit is of defining that is that you do not need to depend on these lowercase letters or uppercase letters anymore. It's a dictionary, right? Doesn't matter anymore. So that can be a great approach as well. Whichever one you like, I'm just gonna go with this one. That other one is as fine as this. So next question would be word break 2, which I'm gonna solve using exactly the solution, and you're gonna see how ridiculously easy it is. So, all right, thanks for watching, guys. See you.